We're good to go? Okay.
Yep.
Hello, everyone. Welcome to today's session of the TAQELAH webinars. It's a pleasure for us to have a very interesting, very experienced speaker tonight, Amesh Gundecha from Standard Chartered. He's been software engineering, agile, and test automation and DevOps expert with 20 plus years of experience. So we're very privileged to have him do a presentation for us. We have a very interesting topic as well about chaos engineering and testing. As always, you can ask questions at the end. Feel free to put your questions in the chat during the presentation, and we'll have Amesh answer them after the presentation. So warm welcome again to Amesh. Thank you for being part of TAQELAH, and yeah, enjoy.
Thanks, Martin, and thanks, Asi, for offering this opportunity to talk today. And thanks to TAQELAH. I think it's a pretty vibrant community in Singapore. So today I'll be talking about chaos engineering and testing. So as Martin introduced, I am primarily working in different areas of test engineering, DevOps, and developer experience in the bank, and I'm also AWS community builder for the developer tools. You can find more about me on my LinkedIn and Twitter handle. So today we'll look at chaos engineering and chaos testing. We'll look at the principles of chaos engineering and how chaos engineering discipline was defined, and then how you can apply chaos engineering and chaos testing in your for your applications or for your projects. And we'll see some demos as well during the session with some of the tools that I've selected today. So, we are in a world, where things are changing rapidly, be it COVID, digital transformation, not just a lot, organizations across the world are moving from traditional data center to more, monolithic architecture to microservices and cloud native systems. The adoption of cloud is priority number for everybody. In any organization you go and talk, everybody's talking about moving to cloud. And if you look at the startups are cloud native, by birth, and they have been building system with distributed architecture, having complex web of microservices. Some of them are using different technologies to build that. And if you look at Netflix, Amazon, they're running thousands of microservices every day in their production. And the other drivers are, as I said, using container technology like Kubernetes or serverless. Now, the distributed nature of system, brings a lot of benefits like scalability and elasticity, where you have your architecture scale up as demand grows, and scale down as the demand comes down. The cloud vendors provide you a lot of features to do that, achieve that. You have resiliency, auto healing, and fault tolerant architecture. There's all the new cloud native platforms provide you a lot of observability, recoverability, with lower RTO, RPO, data durability, and security. With let's say access control network or data security and risk compliance. So a lot of features are offered by today's cloud vendors and some of the container technologies, which is helping drive this transformation. But while all this is happening, there are failures that are bound to happen. And probably last few weeks we have been hearing failures like downtowns from Facebook or from AWS. Entire US East 1 went down a week back, and it also took down all the services that customers are running in that particular region. So Again, there was a cloud. Google Cloud was also down a few weeks back with services like Spotify, Apex, and Snapchat were down. And GitHub, you every week, you will hear that some of these services are impacted because of outages, and there is a lot of press and social media chatter around this. And if you look at the cost of downtime, it is like $5,600 per minute, or it could be like go as much as 300K per hour. And these failures are going to happen because of the scale of these systems, the automation, and what is important is to learn from these failures and keep improving your systems. And in order to do that, the chaos engineering, discipline, came at Netflix. So Netflix was building a highly complex distributed system for its streaming platform, the platform that we use on our mobile devices or we use on our TVs and computers. So the chaos engineering is basically a discipline of experimenting on a system in order to build confidence in the system's capability to withstand, turbulent condition in production. That's a definition that the principle of chaos website offers, and then we'll see what it means in subsequent slides. So if you look at the history, the Netflix introduced chaos engineering because there are a number of reasons for it. They were building a highly sophisticated, complex distributed system, which was cloud native in AWS. And they didn't have a big team to look at all aspects of the system. They wanted to build a SRE team, but they were not Google to invest thousands of SRE engineers. So they started, building some tools like Chaos Monkey or, a set of tools now they're called a Simian Army. And these tools were introduced at different times to basically simulate different types of failures within their architecture. And then use that information to, kind of make the architecture highly available and resilient to failures. There are a lot of unknowns, especially with, they were evolving with Amazon, and Amazon was adding new services, and they were adopting these new services as a customer. There were lots of unknowns that they wanted to test out as they adopt these features, and that's where the discipline of chaos engineering originated. Later, companies like Amazon, Microsoft also joined together because they also saw a lot of value in this. And then these engineers came together and established the chaos engineering discipline. Netflix has a lot of has the biggest contribution to this chaos engineering discipline. They build a lot of tools that are inspired various other tools that are today in the market, be it commercial tools or open source tools that we can use for chaos engineering. Sorry. As we saw, the definition of chaos engineering is about responding to real world events. There are so many things that happen in real world scenarios that you have to look at, like network failures or DNS failures or DDoS attacks. There could be natural disasters, there could be fires, there could be electrical failures. So if you know some of these, Facebook outage was caused because of the hardware failure, or even AWS outage was caused by hardware failure, along with some software configuration as well. But anything can happen within your system, and it has a potential to bring down your system and impacting your customers. Sorry. So chaos engineering is not new, right? Chaos engineering it talks about like injecting faults. So in the testing world, we earlier had fault injection testing. It is a method to kind of inject faults in your system and see how your system behaves, and how it withstands or recover from those errors, right? So we have been doing this for many years. Disaster recovery testing is again, is another technique or discipline that many organizations do to make sure that they have their data center are highly available, and they have like in case of one data center going down, they have another site available, and the systems are not impacted. And we also have resiliency and operational testing, where we make sure that the systems are available, the teams are available to respond, in case of the system going down. So these concept or techniques already exist. The chaos engineering takes it further and applies it to distributed systems. What is the role of tester in chaos engineering? Again, I think the testing community has a lot of relevance in chaos engineering, and it's a good tool to have in your toolbox. With chaos engineering, testing teams can, beyond the traditional testing of, say functional testing or performance or NFT, you can do more with chaos engineering, and especially the distributed nature of system, the automation that it brings along. The testing teams can use the newer ways of testing and newer methods to increase their test coverage. And some of these incidents that you see recently, for example, AWS region was down, though it happened because of a faulty network device, and but that network device fault was triggered by a configuration change, and that configuration change was not tested. That particular code path was not tested, and by knowing that, if you simulate the failure scenarios like that, you can uncover the areas that are not tested, the code paths which are not tested, and you can use that information to enhance your test coverage, add more test to your test suites. It's and also, like chaos engineering at advanced stage, it also happens in production. So you're also testing in production, performed in safely and effectively, especially the distributed nature of the system, the automation, and the changes that we are deploying every day. Thousands of changes are deployed every day. It becomes impossible to test everything. But tools like, or the discipline like chaos engineering can help you, bring more efficiency in your testing. I'll quickly talk about the principles of chaos engineering. So, as I mentioned earlier, the major tech companies came together and defined chaos engineering as a discipline, and there are 5 principles that are defined, and we'll see shortly, how you apply this in practice. So I'll straight away run to the steps of chaos engineering. So in order to implement chaos engineering, you can follow these 6 steps, where first is you basically form an hypothesis, which means you basically find out what could go wrong to your system. So let's say you're building a distributed system with a bunch of microservices. So what could go wrong? So let's say you have deploying the system in different regions and different availability zone. You might come with scenarios where, one of the region can go down, one of my dependent system can go down, my database can go down, So you basically define the hypothesis, and then you also define the steady state, which means that if that event happens, what should happen? The system should automatically recover. System should move to another region, or the database, it should switch on to standby database, or it could it could be a caching layer can also be introduced, so that users are not kind of impacted because of that event. So you basically define your hypothesis. Then, as a next step, you define your experiment. So, experiment is basically how do you recreate that problem. So, let's say you want to you design a hypothesis that one of the nodes in my distributed service system will go down. Then how do I simulate that in event? So I need to create my experiment, what problem that I want to recreate, and then how safely I can create that in my system. And most importantly, it should not impact my users, whether they are internal user or external user. The third step is defining the blast radius. So the blast radius is how the impact of that particular failure will be. So whether it will impact small set of users, or it is going to take down all the services. So ideally, you should start with small experiments or small blast radius, where you do small experiments, and then you build up your knowledge, and you increase your blast radius to kind of find the problems. You run the experiment. So with your hypothesis and with your experiment, you identified what you want to do. Then you run that experiment, and then you either you find a problem. You see that my architecture did not cover the say auto healing capability enough. I need to work with architecture, and I need to increase the high availability of my system. And that's the observation that you made from your experiment, and that's how you can then use it and as an action to improve the system. But if everything goes right, everything works as expected, then probably you can increase the blast radius. You can bring in different experiments, and then you can start again from the beginning. In the end, you conclude your chaos engineering experiments. You identify problems and the actions that that each of your teams will take. Now, chaos engineering is not just about finding technical issues. It is also about human issues, and software development or engineering is also a team play, right? You have development teams, you have testing teams, you have operations teams. Everybody has a stake, and the information that you gather can be useful for all of these teams. For example, let's say there is a fault that you found, but there is not enough monitoring. There is no alert generated for the operations team, or the operation teams did not pay attention to the alerts. That's something that you need to train your team, and basically optimize your alerts, and also make sure that team is available. They understand these issues, and they can respond to those events, right? So it's both technical problems, and the also the team collaboration. Okay. So I talked about experiments. So when we practice chaos engineering, we can define different scenarios. For example, it could be a real world event where network is down. Your network is completely there's a blackout, or your packets are corrupted, or particular dependent system is not available. So There are different experiments that you will think of when you start, implementing chaos engineering, and typically the different types of faults can be used in different scenarios. They can be used as single fault, or you can mix and match to create a real world event. So if I take the reference of the Facebook outage, it was mix of software configuration issues, it was mix of hardware issue, and then the way the network was isolated. So there are different aspects to it. In Facebook issue also, when the issue happened, all the team members were remotely working, and they have to, like, at a short notice, bring everybody back to their data centers. And when they came back, there was no access. And so all these things, you need to combine and then simulate a real world event, right? So there are different faults that that you can use. It could be network faults, it could be resource infrastructure faults, like CPU, memory. It could be application faults where you have um, a memory leak, as well as, or a particular Spring service. Let's say Spring Boot application. It could be some Spring Boot exceptions that could lead to faults. And there are state faults where, for example, a particular availability zone is down, or a particular node is down. So these are different types of faults, attacks, assaults. There are different tools and they have different terminologies. But basically, these are different experiments that you can use together to create a real world scenario or real world failure simulation. So in terms of tools, there are like many tools available today. It started with Chaos Monkey. It is a small library that you can inject in your application or in your environment, and then you can run different types of experiments. So the very basic experiment that Netflix started was randomly shutting down EC2 instances in their AWS cloud, and then observing how it impacted the other component of their system and their operations team. However, now this discipline has evolving, and there are lots of other parameters come in this mix. There are lots of tools coming up, both in open source world and in commercial offerings as well. So I just listed some of these major tools that are available. In fact, AWS and Microsoft also announced their own fault simulation tools as part of their offering. Some of the popular ones are Chaos Monkey, Chaos Toolkit, and Gremlin. Gremlin is one of the paid enterprise chaos engineering platform that you can use. And each of these tools are evolving, and they are bringing different features every day. You cannot say that one tool will fit my case. There could be multiple tools that you will need in your case. So just keep watching and use what fits best. I think in terms of feature-wise, I think most of them provide the same features. The basic ability to define an experiment and execute that experiment. And you really, I mean, in some cases, you really don't need a tool. You can do that using the, let's say, I'll show a demo where we are basically doing some API calls using Postman, and then we are creating a chaos engineering scenario. So with that, we'll turn to demos. We'll look at chaos engineering in action. I'm going to cover two tools. One is the Chaos Toolkit. We will cover the application level fault, and then I'll use AWS fault injection simulator to simulate a fault in the infrastructure. Okay, before I get into demos, I just want to I'm sure that a lot of people here who are Elon Musk and SpaceX fan. I'm a big fan of Elon and SpaceX, and they are demonstrating us the future of travel to Mars using the chaos engineering experiments. So I think they first started with Starhopper. They're working on the Starship, and Starhopper was the first kind of small rocket you can consider as a minimal blast radius. Then they, from Starship SN1 to 8, they did a lot of, tries to fly the rocket and then, land it back. And most of those, tries failed. And in some cases, the rocket was blasted. And, when SN8, rocket landing failed, Elon Musk tweeted, this is a very important tweet, the fuel header tank pressure was low during the landing run, causing touchdown velocity to be high and red. But we got all the data we needed. So this is very important. We got all the data we needed. So when you run this experiment, it's not about whether experiment will fail or pass. It's about data that you collect, and then that data, how do you use it? The developers can use that data to fine tune their algorithms. Testing can use that data to look at the test coverage, add more coverage to their test base. Operations can look at how they respond, what telemetry they have, what telemetry they miss, so they can use that event to collect lots of data and learn from it. And finally, Starship 10, they were able to successfully land the rocket, and probably now they are preparing for the next phase of the Starship. So that's the chaos engineering that's happening in front of us. That's a great example. So moving on, we'll look at the first demo, which is about injecting application level faults with the chaos monkey. So I'm using a simple web service in this example. Let's say you are all cricket fans, or probably in India we have lots of cricket fans, and we look at the team rankings. And let's say you're working on this ICC website, and you're getting data from some database, and there is a service that is running behind this. Now, this is a Spring Boot service. I call it player ranking service. So what we are going to do is use Chaos Monkey and put it into Spring Boot. And Chaos Monkey, we can then control this particular service and inject a fault where the database connection will be blasted. So what is going to happen is we will temporarily inject some exceptions in the service so that it basically tells that the Chaos Monkey will disconnect, simulate the database disconnection, and what users see is an exception, which is not an ideal, and then we iterate on this example. So I'll come to my demo part. I hope everything works. So let me start the buggy version of the app. So I hope you are familiar with Spring Boot. It's one of the popular web services or web framework in Java. And what we did is we kind of started this small app, which is basically running the service for this particular application example that I gave. And in addition to running that application, I have injected the Chaos Monkey, along with this application. It's very simple. If you know Spring Boot and Java, you just add a dependency in your application, and then Spring this Chaos Monkey Spring will you will be able to instrument that application. So now I'll define the steady state that let's say let me make a call to this service, and it is actually returning a list of players and their ranking. Now, my steady state is that when the database connectivity is impacted, the application should still work, and it should either give me some empty response, or it should give me some cached data that it has before the impact happened, right? So that's my steady state, that the service should still run. It should not show any exception, or it should not show me any HTTP code which is which is gonna tell me some kind of exception in the application. Any bad HTTP code, right? So this is my steady state behavior. Now, what I have to do is I want to experiment an application level fault. So for that, as I said, I'm going to use Chaos Monkey, and I need to enable the Chaos Monkey when when I want to experiment, because right now, though it is injected in the application, it is disabled. So I'm using Postman here, and you can do this testing in a Postman. You don't need a tool, to be honest, and you can do it manually. So what I'm going to do is I'm going to use this Chaos Monkey, and what happens is this Chaos Monkey library offers me some additional endpoints to enable and disable the Chaos Monkey and the faults. And I can call these endpoints, and I can send some settings like here. I'm just sending enable, so it will just enable the Chaos Monkey because I want to do a chaos experiment. I need to set some watches. These are basically like to instrument your Spring Boot service, to look at your controllers, your services, repositories, and all, right? That's where we want to basically simulate the database failure, and we want to kind of inject an exception on the repository, which basically represent your database connection in Spring Boot application, right? So I'll send these watchers, and then I'll inject the fault. So what I'm going to what I'm doing here is whenever there is a request to the application, and when it connects to database, it will connect. It is connecting to database, which is in this case it is a Postgres database that is running behind the application, and it is going to simulate the connection timeout, which means it is not able to connect to that database, and then there is an exception generated connection timeout, which will lead to a failure in the application. All right, so I just enable the configuration. Now, if I refresh this, I'll get an error, and this is showing some white label error page, some exception like HTTP 500. I don't want to show this to user, or I don't want to I need to send back some meaningful information. Either I would tell my front end that I don't have data, or I will implement a caching layer, right? So now the developer needs to handle this error properly, right? So for now, I'll just disable the Chaos Monkey because I'm done with that experiment, right? So what I will do is I'll probably show the code where this is where this particular block of code where I request my player list, and then it simply returns. Now there is no exception handling done here, and then there are two ways. One is handle this particular condition gracefully, or you have introduce a caching layer in our architecture. Let's say we handle this error. Okay, so here my developer has handled this in a little graceful manner. So here what happens is if the database fails and it doesn't get the records, then it is going to send back an empty list instead of sending an exception, right? So let me rerun this. I just messed up my code probably with that stash. Just a moment. Just give me a moment. So once the application is up and running, what will happen is uh, instead of showing that exception, the user will see some empty list, or you can also add a caching layer and send the cache data back to the user. So let me come back here in Postman, and I'll just make a call, and it is sending the result back. Now I enable the chaos monkey here, and some of these watchers, and then I'll inject the pod. Now, if I make the call to this service, instead of showing an exception, it is returning an empty array. And then based on that, my front-end developer can say that, hey, probably there's some issue, there's no data. Or if we implement the caching layer, then the data can be, can be sent from that caching, from that cache. So that's how you can do a simple experiment. So here we are just using the chaos monkey library, and then we are doing it in Postman. Now you can do this experiment. You can automate these experiments using the Chaos Toolkit. So Chaos Toolkit is, again, it's an open source tool. And what it offers, it's basically a declarative way to create all these experiments in an experiment file, and then you can use this experiment file and run it again and again. And then the Chaos Toolkit will provide you drivers for different technologies like Kubernetes or AWS or Google Cloud. And there are lots of new plugins that are coming every day, new drivers, and also the Chaos Monkey. So it basically provides you a simple DSL through which you can create your chaos experiments, and then you can run these in your CI/CD pipeline. And these experiments are run as like command line. So you can create the experiment file, and this is how it looks like. Yeah. And this is how, when you run the chaos engineering, chaos toolkit, basically you run your experiment, and let's say, in this case, the steady state behavior was like, it should return HTTP 200, and it should return me a list of database, list of players. In this case, it failed because it was throwing an exception. So our steady state was not made in this case, and then we basically gave that feedback to developers and architects, and they kind of fixed it by handling that particular scenario situation gracefully, and then adding a caching layer. And you run that again, and then you pass. So you can create a library of these experiments like regression tests, and then you can run them again and again in your CI/CD pipeline. The chaos toolkit, it was a simple experiment that we ran. We can have multiple experiments with different scenarios where database connectivity is impacted, a particular service impacted, or any dependent system is impacted. We can have multiple scenarios and experiments together, and then we can run that and evaluate or observe the system, how it behaves in that situation. And then we can collect that information to improve the, if there is a need for improvement in the architecture, or monitoring, alerting, response from the team. So we can do that. Now, you would say, you can you can use performance testing and also simulate such kind of events. For performance testing tools, again, you need to script, and then you need to kind of need a lot of compute power. You need a lot of test data and all that stuff. Which you can kind of eliminate with the chaos testing toolkit. You can directly simulate those events. You can still have your performance testing running along the side, collecting the data for you, but these tools will provide you a better way to perform these operations. All right, so the next demo. What we saw is the application level fault. Now we'll see infrastructure level fault. So what is infrastructure level fault is attacking the infrastructure. So I mentioned about let's say if you are using Amazon Cloud or Google Cloud, you have regions and availability zones, and you can find yourself in a scenario where a particular availability zone, where your application is hosted, is down, or it has issues, or a region is down. So how do you withstand those kind of situations? How do you have the application highly available and fault tolerant on this? So again, I'm using AWS fault injection simulator within the AWS environment. But there are other tools like Gremlin or others can also support that. FIS is, if you're on AWS cloud and using that for your application, this can be a handy tool for you. So FIS is a managed service provided by AWS, and then you can define these fault injection experiments and run them. It supports different AWS services like EC2, which is a compute service, RDS database service, or if you are using EKS, which is Kubernetes, you can also use FIS to simulate pod failures and other things. What you do is simple. It works along with your it comes in your AWS account, and it then get access to your VPC, your virtual private cloud, and your subnets and your resources. You basically have to create an experiment template similar to what we did with the chaos toolkit. And then in that experiment template, you basically define, what action that you want to simulate, and then you obviously use CloudWatch, which is AWS's metric collection system, and then you can define at what point we need to halt the experiment, or if we don't want to halt, then especially in production or staging environment, if you want to do, you also need to think about what are the stop conditions or halt condition that you need to have as part of your experiments. And typically when you do this experiment, you can start with dev environment, and as you get more confidence, you go to staging, and in advanced stage you can go to production as well, right? If you're confident that you can run the experiment with a defined blast radius and without impacting your user. So it depends on how mature the team is, and then you can use these experiments and then run them in environment that you want to observe. So coming back to the FIS, so basically you create a experiment template, you define the target, the application infrastructure that you want to target, what actions you want to take, and what are your stop conditions, right? So I'll run a simple FIS scenario or experiment where if you know about AWS cloud and the cloud elasticity, which means AWS provides auto healing capability with auto scaling group, and our architect said that we build this application highly available and fault tolerant. How do you prove that? You can prove only when you run in production and lots of users hit, and then the auto scaling kicks in. what happens if it doesn't kicks in, and then how do you evaluate architecture is highly available and fault tolerant. So what I'm doing here is I have a simple web application that is running in a region within a VPC, and then I have created an auto scaling group. So auto scaling group is basically defines, like what is the minimum set of servers that will be running, and how those will be distributed across these availability zones. And then, let's say there is an event where, there is let's say holiday season is there and there is a sudden demand, then how does system scale? How it will scale? So I will define that. And then what happens if a particular availability zone goes down? How the system resources will be procured in another availability zone. So if we have to test these scenarios, then we can use the FIS, and it doesn't need a very last setup. You can start with your application blueprint. You can create a staging environment or a environment to run these experiments, and then you can run different types of infrastructure actions. Like what I'm going to do is I want to test the auto scaling loop, where what I have said is if the average CPU utilization of my servers increase by over 50%, then I need to create a new instance, and then the traffic should be distributed across the availability zone. So that's the architectural decision has been taken in the architecture, and then we want to evaluate that. So we'll use the action where we'll kind of use the CPU stress, where we will make the CPU go beyond 50% utilization, and then we'll check whether the auto scaling works or not, by where it automatically adds another node. And the other experiment is killing the EC2 instance. So just imagine an availability zone it goes down, which means one of the instances is terminated. Then what happens? With the system, the logic that is defined in auto scaling group, does it brings another server? So let's do that. So I'll come back to my screen here. So as I said, I have these two servers running, and I have defined all the auto scaling and load balancer configurations. As I said, these servers are by default running, and as per my architecture, if there is an increase in demand and CPU utilization goes beyond 50%, then it should add another node. So I need to run that experiment, right? Right now, I'm running these two nodes, and everything works okay. Now I want to create a traffic or a situation where more users are coming into the system. So that's why I can use this FIS. I can create a new experiment template. You just say auto scaling. Okay, just copy this. I've already set up some of the roles that are required for FIS service to access my system resources, because it requires some privileged access to manipulate the infrastructure. Now I'll add the action. In this case, as I said, I want to stress the CPU. And FIS offers me a library of actions that I can take. So you can see reboot instance, stop instance, terminate instance. There is action for CPU and run CPU stress. So this is the action that I want to run. And then I have to provide what is the target, where do you need to execute that. So I say instance target 1, because I will define that later. And then I need to tell how much time it should run. So I'm going to give some duration here as the parameter here. So I guess it's duration seconds, and I will say 400 seconds. And then I need to tell how much, time it will, the entire test will run. So I'll say maybe around 6-7 minutes. And I need to save this action. So I can go and more actions. Right now, I just selected one action, which is stressing out the CPU. And this is the target. So I need to define, which are the instances that I need to target in this case, right? So I'm going to use all of these are web servers, so I can use tags and I can say any instance where role is web server. I want to target these servers. All right. And once I'm done, I can save this experiment. Thank you. And then I can, start the execution. So this is going to take a lot of time, and the interest of time, I'll just switch on to my pre-recorded video where we will see how this experiment was executed. So coming back here, I'll just go on here. So I just created that particular experiment. I added a CPU stress, and I kicked off the experiment. So it will get into running mode, and we'll see, during the experiment what events happened. So you can see here, it first went into pending state, and right now all my instances are healthy. There is no issue. The experiment is running behind, and it will slowly start stressing my CPUs. And at this point, the website is working properly. There are no issues. Again, all the both the instances are healthy. Now, during the execution, one of the CPU has, is stressed beyond like 50, it has almost reached 59%. Now, at this point, I should see the auto scaling or auto healing, algorithm should kick in, and it should add another instance to, support the demand that is coming in, right? So one of the instance has hit that limit, and you can see that the auto scaling algorithm or the feature has added another instance to my infrastructure, and again the traffic is evenly distributed between different zones. So which means whatever the auto scaling algorithm that I have defined for the system is effective, and it is working as per the steady state behavior that I have defined, right? And then it basically will continue. It will continue for 7 minutes. And what happens is after the experiment executed, and as the CPU demand decreases, it will remove the instance as well. So I'm also testing whether I am getting right notifications. So this did generate a notification. So my team was got an alarm that auto scaling was kicked in, and it created a new instance. And then I can observe the traffic for some time. And once the traffic goes down, which is in this case, average CPU utilization goes below 50%, it will automatically remove the instance, because I have configured that way that it will only add a new instance when there is a spike in demand. So we can use the fault injection simulator in this way. I will, what I'll do is I'll run another scenario, very simple scenario. So let's say another, design or another architecture design that we have done is that the auto scaling should always have, 2 instances running. So if I terminate one of these instances, let's say EC USS2C goes down and the instance is terminated, then it should automatically provision an instance for my use. So I want to create that experiment. So I can go to FIS And let me create another quick template. I'll create an experiment and I'll say terminate. Okay, and I'll provide the FIS role, add action. So here I want to terminate an instance. We can see there is a terminate instance action. And I can tell the target group, which target group I want to, I want to terminate. I'll say target one. I can give some start after and other optional arguments. And here I can select which instance I want to, terminate. So first let me save the action. And here what I'll do, instead of tags, I'll use the IDs and I'll terminate one of the instance that is listed here, right? Okay. And that's it. I'll create the template. Now you see there are two instances running, and now I'm going to trigger this experiment. So I'll say start this experiment. And you'll see one of the instances will be terminated by AWS fault injection simulator shortly. As it gets into running. Okay, it's already completed. So one of the instances is being terminated, the one that I selected, and shortly the auto scaling group should add one more instance to kind of recover from this failure. Okay, so once it is terminated, so there are certain timeouts that I have put. Once those timeouts are reached, it will come back and add the instance. Okay, in the interest of time, I'll just move on to. So, what are the benefits of chaos engineering? Very quickly, I'll summarize. Basically, the idea of chaos engineering is to discover your system and find the what could go potentially wrong in your system. Find identify the incidents ahead of time. And also prepare your team, train your team for when the incidents happen. So you have right monitoring, you have right people on call, and then you have documented your run books. Especially if you have SRE teams, then they know the operating procedures when things go wrong. Because if you look at all these outages that happened, some of these outages have been recovered in in half an hour or 1 hour. Some took a little longer, but what really helps is learning from these incidents and documenting some of these incidents as a run book when such things happen, then how teams should respond. So you use this information. And earlier I mentioned, everybody can learn from this within the team, and it is a kind of a team exercise. How do you get started? I think one of the best ways to arrange a game day. It is like typically 2 to 4 hour event in maybe a Friday evening. You identify a experiment, a scenario. You gather your team and then you execute that experiment. Then you observe your system, collect the data, do your debrief. If there is any incident, observe during that experiment. You review that incident. You automate that incident, and then you can analyze, publish results, and take action. So, let's say the engineering team has some action, testing team has some action, operations team has some action. So you maybe improve your user manuals, run books, or testing team can help in automate that. So, each one, as I said, has a part in it, and you can use these game days, as a like a mini hackathons, and use the chaos engineering. So that's it. That's all about chaos engineering. If you have any questions, I'm happy to take those questions. Let me also check in the chat.
Yeah. Thank you, Anmesh. Yeah, we have a couple of questions. Thank you for the very interesting talk. Yeah, if you have any favorite question, you can pick and choose. Otherwise, I recommend we start from the top.
Yep.
So,
yep. Thanks, Martin. Let me go through this list.
Otherwise, I think Ankit's question is quite interesting. Are there any prerequisites for teams in terms of process testing that need to be in place before they can embark in chaos engineering? So like asking about the requirements to do this or precondition.
In fact, there are no prerequisites, and the way chaos engineering discipline used in Netflix, there were no processes, and it basically started as a random set of activities to kind of discover what could go wrong, and literally in production, their admin could, without anybody's knowledge, they could just terminate any of the instances and see how everybody responds, and use those observations to fix any gaps in architecture, fix any gap in testing operations. So I don't think you need any prerequisite or any plan for this. It has to be random at some times, and surprise as well, because that's that's where you get more value from these experiments. If you tell ahead, people, fire drills, they can be relaxed and having coffee when these experiments are run. So you should have element of surprise, and there should not be any prerequisite.
That makes sense. Thank you. Then we have a question from Gaurav. When we're doing hypothesis, can we do this testing like non-functional test instead of having it in production? So I think question is around the test environment. Does it only make sense in production, or can you also test it in other stages?
I think you can test in any environment. You can start with small experiments within dev staging, and once you build that maturity, you can do in production as well. Netflix that does that in production. They would randomly fail something, and very small user base might experience their profile mixed up or their profile completely gone. I have personally experienced that once, where my profile, there was no recommendations displayed for a few seconds or few minutes. So yeah, I mean, if you are it all depends on what kind of application you're trying on. If there is, let's say, if it is a financial product or bank, probably you cannot do that in production, or you have to do it very, very carefully. Because there will be a impact on your users, and it can have the financial implications. But if you're running service like Netflix, you can bring it down for a few seconds or a few minutes, where small user base can may not have the some of the features available to them. But yeah, I mean, at least you can start with dev. And then especially with cloud and containers, you can automatically create environments, run this test, and tear down, right? So yeah.
All right, thank you. Yeah, let me jump to Prakar's question. We have always thought about this discipline as logical but exploratory. I think like deterministic but exploratory. Is that the right thought process? I think that's an interesting question.
Yeah, it's a bit of exploratory, but again, you can bring in a little structure when you actually execute your experiments. They are not at all open. Like, let's say you want to do something, you want to look at infrastructure issues, then you define your, your hypothesis, your steady state, and then define if that thing has to happen, then what experiment that I need to use, and you use it. So you do have some structure to it. But what you are exploring, you might gather a lot of information during that experiment, and that information offers a lot of value. You could find things that you are not at all unknown to you. You may not have, have in your telemetry in production or in your monitoring in production. So yeah, I mean it's a bit exploratory, but it can also be structured.
Okay. Yeah, I think we have time for maybe 2 more questions. There is one from Gaurav as well, and Ankit also highlighted it once more. Do we have a standard definition of what should be tested? Like he's referring to the OWASP like top 10, I guess, for security testing. Is there something similar, like a playbook for chaos engineering? And maybe related to this, there's another question: which are the weakest links in a large system? So what are the areas that are most likely to fail, where chaos testing could be most useful? So is there like a checklist that people can follow, or is it more complicated than that?
No, I think, I talked about different types of faults, and those faults can lead to, different things. So that can be used as a checklist to guide your experiments. I mean, it depends on what you want to test. Say, I want to test my infrastructure. So what are all possibilities that you have? So that list of faults can give you different possibilities. But again, it again depends on what you're trying to find out. Let's say, I know example where the availability zone, high availability of the system. The typical scenario is to see whether auto healing or auto scaling logic works or not. But in production, sometimes let's say AWS cloud, you could do things which are probably unknown. You can have when for auto scaling to work successfully, it needs to have, let's say, right IP range defined. And if you have, let's say, you expect a system to scale hundreds of instances, but you don't have those many IP addresses assigned, your auto scaling group will not work, right? So that's kind of blind spot, right? And so and then it opens other possibilities as well. So I mean, you can use that checklist as a start, and then there are, again, down the line, there are lots of other things that will impact or that will you need to consider in your scenarios.
All right, thank you so much again. I suggest we have time for one last question. If we have anything still from the audience. Otherwise, I'd go with, I think it's Jagan. How often and when should we do these chaos experiments? Will it be part of SDLC? Like other testing? I think you covered some of that, but oh yeah, we have a question from Prakash as well. I don't know, Sham, whether we can unmute people. I think you can just put it in the chat. Yeah, maybe Amesh, we can go with Jagan's question first.
Yeah, I mean, you can start, as soon as you have your system running in your dev or staging environment, and you are ready to experiment your architecture decisions, your design decisions. You can start early as possible. make sure that you have the right automation to create environments and run these experiments and kind of wind up. I would say it should be like an ongoing exercise. As your architecture evolves, you should keep it doing as and when you make a decision that hey, we want to change caching. So yeah, let's do some experiment to evaluate options that we have. Right. So I think I've said in game day here, you can try the new experiment or new tools or evaluate your deployments in new environments or any architecture changes. So you can use these events to run your chaos engineering experiments.
Okay, thank you. Yeah, I think we're quite a bit over time already. Thanks for all the great questions. Was pretty good contribution during the holiday season, 4 days before Christmas. So thanks everyone for joining and for asking quite insightful questions. And of course, thanks a lot again to Umesh for very insightful and interesting, and I think also quite helpful presentation for us. And yeah, I think if you have any questions, maybe Anmesh, you can share how people could connect with you. I think the contact should be on the slides. Maybe we can figure out a way to answer some of the open questions after the presentation. I think the slides will be available as well. As Sham mentioned before, there's also a recording of this session. And yeah, with that, thanks once more. And